So you might want to take a look at that again. Just, like I say, it's a really, really good review. Okay, then over here, according to the NRC regulations, the annual occupational dose to any organ or tissue other than the eye is, 50 grams. The trend seems to be that they're going more to sieverts. So again, keep in mind you may get one or the other, but both of them are still legitimate. Okay, and then the next thing, according to the NRC, the annual exposure to members of the general public must be limited to no more than, okay, remember it's 1/10 of our allowable dose. So you guys are allowed 1 rem per year times your age. Remember that's your cumulative dose. So the general public is allowed 1/10 of that, which is equal to 100 millimeters. Right? 0.1 rem?
That's the new standard 1 rem times the age.
Yeah.
That's the max yearly dose.
Yeah, because we talked about it before. You have a quarterly dose. You have a monthly dose, a quarterly dose, an annual dose, and a lifetime dose. Okay? So your lifetime dose is calculated by 1 rem times your age in years. Okay? So that means the general public is allowed 1/10 of that. Then the next thing down here we have is number 140. If you have a pregnancy, okay, remember you're allowed 0.05 rem per month, and since it's based on a lunar month of 28 days, that's 10 months. Okay? So this 0.5 rem during the gestational period. Okay? They usually ask you a question about that.
So the lifetime dose was age times rem.
Yeah, lifetime dose is age. And they call it either your cumulative lifetime dose. It's sort of like your bank account, because if you exceed that, then you can't work. You're out. You're put on the sidelines. You're put on the bench. Okay. This one here. What is the minimum length of time that 131 must be held for disposal? Yeah, 10 half-lives. So whatever the half-life is times 10. So iodine is 8 days, so 80 days. Now, the other thing is that 10 half-life rule applies to radionuclides that have half-lives of how long?
Short ones.
Well, we know there's an actual number. Yeah, what's the maximum?
120 days.
120 days. Okay. So 120 days.
That's the max. You got
Any
isotope with a 120-day half-life.
Yeah. So any radionuclide that has a half-life of 120 days or less can be stored for 10 half-lives before you dispose of it. Okay. Next one. But again, remember at the beginning when I was making you guys learn the half-lives and the energies and all that? This is where it's going to come into play. Because on radiopharmaceuticals that we use a lot, they're going to expect you to know the half-lives. You might say, oh, the half-life of iodine is 8 days. No, you better know that it's 8 days, because they're not going to tell you that. So then you have a vial that's been decayed for 80 days. To dispose of the vial, you should monitor it and make sure that it's down to background before you dispose of it. That's the truth. Right? Okay, next page here. Boy, we're almost down to page 1 here.
What happens, how do we degrade things with half-lives greater than 120 days?
Well, those you're going to probably have to, a lot of times you have to put them in a 50-gallon drum, spend exorbitant prices to ship it off somewhere else. Yeah, it's, there are companies that will dispose of it, but what they do is they put it like in a long-term storage location.
For years?
Yeah, like they'll send it, they used to send it to Las Vegas. They have these underground salt, where the Bonneville salt flats are. Oh, come on.
Salt mine?
Well, you know, it's this lake bed where they do the racing. You know,
Oh, yeah.
the Bonneville Salt Flats.
Yep.
Okay, that whole area used to be an ocean. And underneath it, they have like these big caverns that they've dug out where they store all the radioactive waste.
Oh,
Is that safe?
Yeah. Well, I mean,
Like if you're standing.
There's a fence around it probably, right?
But you can race
Still.
on there, like if you're racing.
oh no,
on there,
well, it's in that part of that same complex, but it's like in Las Vegas.
Oh, I see.
Because the Bonneville Salt Flats are in Utah. But see, that they extend way up there. But they started, you know, when they had all this radioactive waste after, you know, developing atomic weapons, they had no place to put it. And so, you know, right now, California, Arizona, and Nevada.
Send it off to space.
Well, yeah, well, they were going to do that. They actually tried putting it in containers and dumping it out in the ocean.
What?
Yeah, well, the problem was the containers after 50 years, the stuff from the early 50s, it's all eroded and it's leaking. Oh,
So
yeah.
they did do that?
Oh, yeah, absolutely.
So speaking of.
They throw everything into the ocean.
Well, yeah, but I mean, that's one of the problems is
Out
that
of
they,
sight, out of mind.
Yeah. they try different things, you know, it's like,
Space is the best.
I probably am, it's right in the sun.
yeah, shoot it to the sun or something, I guess, I don't know. Anyway, the next one here. Okay, to comply with NRC regulations, all the following radioactive waste disposal must be retained indefinitely except, transfer for burial. Okay, they don't do this too much, but this is the stuff that they would be doing up in Las Vegas, the real long-lived, dangerous stuff like uranium. The incineration, now what's the problem with incineration?
It's up into the air.
Does the radioactivity get destroyed?
No.
No, nothing happens to it. So basically, now you're sending radioactive smoke out there. But usually if they're going to be like your syringes or things that are plastic that you can destroy, they'll be incinerated, but they're not going to be in a situation where anything leaks out. Okay? The sewer system, you are allowed to release a certain amount of radioactivity into the sewer system, provided you have enough material to dilute it. Okay? Most hospitals, I don't know if you're aware of this, they have a huge underground like storage tank. So all the stuff that from the hospital, it goes into this huge storage tank area for a while, and then after it sits there, then eventually it's allowed to go into the regular sewer system. But the thing is, anything that your patient excretes is not counted. So anything you inject or give the patient, yeah, basically. But I mean, this thing here, the patient's excreta is not considered part of the stuff that goes out. So anyway, the stuff that has to be retained indefinitely, the stuff needs to decay in storage. Once it's down in the background, you can get rid of it. Okay. NRC regulations, which of the following materials are exempt from any limits when discarded into the sewer system and patient excreta. Somebody suggested that if you have any radioactive material, you should give it to the patient. Just here, eat this, and just get rid of all your stuff that way. Patient's done. Okay. According to the NRC, the following radionuclide decayed storage and preparation for disposal except. Okay, why is cobalt 57 a problem? Huh? What's the half-life?
30-ish.
Sure.
Okay, well remember, cobalt 57,
Again.
120 days. Oh shoot.
You watched that again.
Thank you. That's what I got.
Yeah, cesium is 30 years. But again, you kind of see why you need to know your half-lives. Because they will give you a question that says, okay, which of the following has to be, you cannot just get rid of through regular storage or whatever.
14 days for phosphorus with strontium.
It's about 30 days.
Is it because of the longest half-life? Is that why?
Yeah, remember, anything that has a half-life of 120 days or less can be kept for 10 half-lives. And cobalt 57 has a 120-day half-life. No, I'm sorry.
27.
27.
Yeah, 127.
Hmm?
Yeah, it's cool, man.
What?
120 range by
Oh, it's 207.
270 days.
70.
Yeah.
9 months.
Okay, so that's the thing, so 270 days, and the rest of these are under 120 days. Okay, which of the following practices are consistent with the LARA concept as described in regulation? Okay, notice it says lining the room walls with lead, that's to protect people on the other side. Okay, the bad news about our radiopharmaceuticals is that they're such a high energy, you have to put a lot of lead in the walls. That's why we typically don't have a lot of lead in the walls. What do they normally do with us?
Seclude us.
Huh?
I just in the corner.
Yeah, you're in the basement, in the deepest, darkest part of the hospital where nobody ever goes. Yeah. Okay, but that's the reason why, is because it's too expensive. The walls, I don't think would be able to support the amount of lead that we need. Okay, go, remember this one. Okay, why does P32 have to be,
Beta.
Beta.
Emitter.
it's a beta emitter? And what type of radiation would be emitted if it was in a high atomic number material?
Right.
Okay, Bremsstrahl. Okay, is it all coming back a little bit? Okay. It says, which of the following dilutants is recommended for I-131 sodium iodide solution? Okay. Purified water. First of all, bacteriostatic saline. This was stuff where they had materials in the water that was to prevent the growth of bacteria. That would interfere with the binding capability of iodine. Remember, iodine, in order for it to go into the thyroid, has to have what type of a charge?
Negative charge.
Negative charge. This bacteriostatic water actually interfered with our labeling. See, the bacteriostatic water was so that you could use multi-dose injections of saline. Okay? And we don't normally do that. Normally our stuff is a single use, so whatever you drop and inject, you just throw it out. Okay, the tap water, and again, tap water has a lot of undissolved minerals in it. Yeah. In fact, sometimes what they do is they'll put EDTA in the water, and that kind of removes those chemicals. Okay. So, but this stuff is pretty common here.
I see that in a lot of foods too, EDTA. Why is it in everything?
Well, it gets rid of a lot of chemical impurities. I mean, the problem that we used to have is like, especially with the chemicals that we used in film processing. So if you go from, let's say, Arrowhead, where there's hardly any chemical in the water, down to Long Beach, where it's, a lot of stuff in there, the water is so hard that the chemicals don't really react. I don't know if you've ever seen the difference between using soap in soft water
Yeah.
versus soap in hard water.
Yeah, a sales guy came to my house and did that.
Yeah. Basically,
It's a lot more
you get a lot more suds. If you wash your,
water.
if you wash your car with soft water, all the dealerships, when they hire people to wash the cars in the parking lot, they use soft water because there's no residue on
So
it.
the micelles from the soap are also taking away all the junk in the water too, right?
Yeah.
Oh, dang.
It makes the water more efficient and cleaner, and the chemicals don't interfere with
all
the.
the dissolved solids in it.
Yeah.
Wow.
I heard that if you have soft water in your house, you don't even have to use conditioner and all your skin doesn't get dried out as much because the water isn't as hard on your
You don't even
skin.
need lotion.
Yeah.
Okay.
And you don't get scum on your
Yeah.
your shower walls or anything like
Yeah,
that.
there's no shower scum.
Calcium in
Everything cleans off.
But it's expensive.
And
it. Need that
like
system.
refrigerator, your washing machine lasts longer. Everything is better.
Yeah.
Dang, he sold you. How much are you making?
Did you buy the soft water thing?
He wanted like 12 grand for it.
Oh,
That's
that's
expensive
expensive.
setup.
Right.
Don't you need it for?
Forever.
Do you got, Ashley, do you have soft water?
No, my fiance, his family used to be in the
Don't you refill
hot
all
water
the time?
business with solar. They used to do solar heart installations.
Uh-huh.
And so, we used to talk about the Insta hot all the time and then the soft water stuff, so that's why I know about it. I wish I had this, but I don't.
No, I mean, it's really good, but you gotta buy salt all the
You gotta
time,
install to your house.
and it wastes a lot of water too.
Awesome though.
It is awesome.
It's
I love
so
I
it.
good.
mean,
after
wash
shower.
your car and stuff.
You
it's
have,
great
you got
stuff.
it?
My friend's condo, Laughlin has it, so when I go to Laughlin and stay at the condo, like, it feels great after showering.
You don't even use soap.
Let's take a look at number 150 here, guys. Okay. Which of the following monitoring techniques should be employed to rule out
God, you
internal
gotta ruin my
contamination in
recording.
showers? Okay. This is your bioassay. So normally what they're going to do is they're going to take a urine sample and they're going to put you underneath the uptake probe. Okay. So thyroid uptake 24 hours after handling a solution. Okay. Sound good? This other stuff isn't going to usually work because remember that, well, if you were going to,
Is this for, sorry, is that for patients or for?
that's for
us?
you. Yeah. This is for internal contamination because remember, you have what we call the total effective dose equivalent and the deep dose equivalent and the committed effective dose equivalent. So the committed is what you're looking for here. That's the, well, that's your internal dose.
The internal dose goes by another name, right?
Committed effective dose equivalent. Okay. Okay, according to NRC, areas where radiopharmaceuticals are prepared, administered must be surveyed daily, unless you don't do any patients that day. Okay, but then what happens is that the inspectors look at your logs for that particular day. If you did any patients, then there better be a QC for the camera and surveys and all the other good stuff. Even on weekends. This is where they used to nail us a lot. You get called in on the weekend and you didn't do a flood or you didn't do your dose calibrator stuff and you got nailed. Okay, NRC wipe tests of areas where radiopharmaceuticals are prepared or administered must be performed weekly. And make sure you guys know how to do that. You get your long-handled forceps. You never do it by hand. Yeah, so we use long-handled forceps to do this stuff. Okay, performing a room survey with an in-window GM tube, the technologist should first, okay, that makes sense, doesn't do a battery check. Okay, this is what I told you guys, you need to do a battery check.
For the wipe test, we have to hold like the wipes with the syringe, I mean the tongs.
Yeah, I would.
What about like with clean gloves? Could we?
Well, if it's contaminated, then you're going to get zapped.
exposure?
Yeah.
That's true.
You have to make the assumption that everything is possibly contaminated.
I see everything being done wrong.
Well, there's the right way and then there's Mr. Radke's way. Okay. So technologist is measuring, and again, you'll see questions like this. Okay. Technologist measuring room background with an end window. Now remember, end window means that the end of it is open, because there's also side window detectors, and it has the opening on the side. Okay, but these ones are kind of like a pencil because you use it to identify areas so you can see how large an area is contaminated. Okay, so you're measuring room background with an end window. The meter shows the following reading. What should you do next? Okay, yeah, because remember, you're down here. This is one of your least sensitive regions. The area that you wanted is somewhere between the 0.5 and the 1.5. You want it somewhere in this region. So what is it actually measuring right now?
About 10? No, because 0.1, almost 0.1
So
and 100.
0.1 times 100 is,
That's 10.
so this would be 200 here, right? So 200, this would be 50, yeah, 40, 30, 20,
Just say
it's
10,
about
you know.
10. Okay, so, yeah, if you moved it to the 10 scale here, where would it be?
It would move up to 1.0.
Okay, we move right here to the center, correct? And they'll ask you a question like that too. You say, okay, the technologists have this setting, you moved it to the times 10 scale, where would it be? It would be there. Where would it be if you went to the 1 scale?
It would be off the chart and just be
Exactly.
bouncing like that. Yeah.
It would be off the scale. So that's what you have to be prepared for. is when you're using these things. Okay, the next one here, okay, which one of these, when surveying for decontamination, or for contamination, which of the following diagram depicts the correct position of the probe for an end window? So remember, here's the part where the opening is for the radiation. That's an end window. Sometimes they'll put it on the side. That would be a side window. Remember that it has that metal thing that you can use to open up what they call the beta window. Slides out of the way. Remember I showed you guys that a long time ago? Okay, so which one of those would you use? Yeah, one that I circled. One correct answer that I circled. Okay. Here you don't really get an idea where the radiation is coming from. Here you're far enough off the ground. Now why do you think they only go a half an inch?
Because you don't wanna lose.
You don't want to touch
You
it.
don't want to contaminate.
Yeah, right. If you have it like down here, you're contaminating it.
It's gonna be reading high all the
Yeah.
time.
So if you went to that other school, that's what you'd be doing. And up here, why? Okay, now this is 6 inches. Why are they not doing it at six inches?
Well, it's too much, not be too sensitive.
Too high.
Yeah.
Yeah, remember that beta particles don't penetrate things very well. And even at here, you're only going to detect high energy beta particles. The low energy beta particles will not go through the end window. Okay? The high energy ones will. Make sense? And here the remember beta particles don't travel that far.
So the air complex, an inch or two.
Depending on the energy, they'll travel about maybe anywhere from a meter to a couple of 100 meters, depending upon how high an energy is. But if it's a low energy beta particle, it's not going to do it. I don't know why this thing does this. Because I put my hand on it, that's what it does. Okay, then the other thing is, to comply with NRC regulations, which areas must be surveyed for daily contamination? Yeah, any place where you're using radiopharmaceuticals. And this got a lot of hospitals in trouble because the cardiology department, they were injecting patients with thallium and sustamibine following a stress test, but they weren't monitoring it. Also, any bathrooms that you refer patients to have to be monitored on a daily basis. That's the latest thing that they were hitting people with, is where's your bathroom?
So that doesn't mean a white test, that just means get the GM and walk around with it.
Yeah. Okay, then this one down here, they're going to ask you, okay, what's the radiation reading on this?
That's
60.
60.
Okay, yeah, so if you're looking at the MR per hour,
No,
it's at
that's
0.6 times 10,
10, that's
so it
6.
should be 6, right? Okay,
The back comes
so make sure that you remember how to do those. Okay, and then what is the measured exposure rate on this one down here?
That's 1.8.
Yeah, it's 1.8 times 0.1.
So 0.18.
0.18.
So that's less than background, so it's okay.
Actually, yeah, I mean,
Oh,
this,
yeah, no.
yeah, the thing you gotta be careful of is making sure that you know what your background is, because it does differ from place to place. That's why I said, normally, anything below 2 MR per hour is considered safe background, but normally it's a lot less than that. I think my hospital was about 0.2 or 0.2.
0.02, right?
Yeah, 0.02. Okay, what is the maximum exposure rate that can be measured with this GM machine below?
50 MR per hour?
Oh, yeah, 50.
Okay, yeah, so the times 10 scale multiplied by 5. Okay, so 50 MR per hour. Everyone okay on that?
Yeah.
Okay, then during a routine room survey for radioactive contamination, the technologist identifies an area that exceeds the trigger level. Okay, normally you're the one that's going to determine what the trigger level is. Most people will say anywhere from 2,200 to 2,000 DPM per 100 centimeters squared. But remember, I told you that the typical classification is 22 DPM per square centimeter. Okay? So, it says, which of the following should you do next? Okay, you found an area that exceeds the trigger level, what do you do next? Okay? And notice it says you do a wipe test. Because if you do the wipe test and there's nothing on your filter paper, then there's nothing else you can do. So you're just basically going to cover it, put down what the radiation reading is, and keep people away from it. Okay. Then which packages must be wipe tested? Yeah, all of them. Again, take a look in the math book. Make a little note over here. There's a chapter that talks about applications of doing wipe tests. Remember that chapter where it said you have an efficiency of 50% and you get so many CPM? Are there any areas that are contaminated? Okay, so a lot of times you need to remember that. If you have 1,000 counts, the efficiency of 50%, you may, how many DPM is that? Okay, it's 2,000 DPM. So depending upon the size of the area that was wipe tested, that could be contaminated. If it's a small area, you get 2,000 DPM. That's not good. So all of these ones do have to be wipe tested. Okay, and this one here, there's a mistake. Okay, according to the NRC, the final delivery carrier must be notified if the exposure rates of a package exceed, and that should be 10 MR, okay, and 200 MR at the surface, and 10 MR at the package. 200 MR at the surface and 10 MR at 1 meter. Okay. So just keep that in mind that there is a mistake there. When opening packages, okay, first thing you should do, make sure you got gloves on, right? Then you should measure it. What should you do first? Okay, you put the gloves on, then what do you do when you look at the package?
Survey it from far away.
Alright.
Yeah, survey it at 1 meter. Okay, then you can survey it at the surface, and at the same time you're looking for any damage.
So you survey the 1 meter first before the surface, not the surface, not like any order?
Well, what would happen if you monitor at the surface and you find you just got a lethal dose of radiation? Then you really feel bummed about that, huh? Okay, so you monitor the radiation from far away, and then as you get closer, you can adjust your scales. Because if you turn it on and you're right, it's sort of like, being out in the ocean and realizing you're in a shark feeding thing.
Which no one does, we just go straight up to the packages.
Oh yeah, I know.
Like, what the?
No, I mean, in all of the years, there was only one situation where I know where there was some kind of a vial that broke or a syringe that leaked or something. So the thing is, it doesn't happen very often, but it only has to happen once, and then you're in trouble. Okay, technologist monitors the empty carton from an I-131 shipment. The container measures 0.85 MR per hour. Room background is 0.8 MR per hour. So what should you do next? Okay, so basically it's a background. Yeah. So basically just obliterate it and throw it out in the regular trash.
But it's not background, it's 0.8.
Well, the background is 0.8 and the
Shouldn't
container
it be
measures
less than
0.8.
0.02?
Yeah, 0.05 is not considered background. They're not considered high background. Remember, you
So
don't.
what is like that cutoff?
Well, 0.05 plus or minus is not within. That's within reason.
Within 10%?
That's within 10%. So
In a few hours.
that's going to be, if it was like 8.5, then yeah, you got a problem. But if it's about the same as background, you can toss it out and not worry about it. You guys want to take an early lunch?
How about we just finish it?
Yeah,
Can we just
finish it?
Just do
Yeah.
Paul.
Okay, actually, it'll probably take us. Okay. okay, radioactive spill. Remember, there's a whole section about radioactive spill. Normally, okay, you want to let everybody know that there is a spill. That's one of the first things you do, and then you want to try to contain the spill if it's a small amount. If it's a big amount, then you get the heck out of there, change your name, and tell them somebody else did it.
Go to the next.
Okay, anyway. Radioactive spill involves contamination of life-threatening injuries to personnel. Which of the following should be done? Okay, you will be doing CPR and things like that on people who are radioactive. Okay?
Huh? What?
Yeah,
Oh,
if you have, let's say that there was an explosion in the nuclear medicine department, or people are injured, they're contaminated, you basically disregard the fact that they're radioactive and you
So we
treat
get
them.
contaminated too?
Yes, ma'am. Because you know how to work that equipment.
One die rather than two.
You'll just die later. Okay, you'll just die later.
Good. Found the quiz.
Now, misery loves
I'm not
company, so you
opposed.
both might as well get, treatment for radiation.
Okay, CNS.
Yeah. Okay, the first step in the decontamination of personnel is, okay, notice. You don't want to remove the person from the site of the spill because now you're spreading the contamination. You don't want to wash the contaminated area yet because in most cases the contaminated water is going to go all over the place. So unless you have a mechanism where the water is diverted, if you actually have like a hazmat situation, you can wash patients off like a shower outdoors with a drain right there. And stuff, so that the stuff doesn't go. You take off the clothing.
I have a question, say like patients coming out to Nuc Med and they vomiting on the towel, whatever. And we just throw it in a linen cart, and then people don't know that's contaminated, so they...
Oh dear, you better not just throw it in the linen cart. You're supposed to monitor it, and then if it's still radioactive, then
Or
you let it decay.
put it this way. We send the patients back to their room,
Yeah.
and then they vomit in the room. And the nurse or whatever didn't know or whatever, and then they just throw it in a linen cart, so it's not our fault.
Well, then the alarm goes off when they send the stuff out of the hospital, and then if it gets to the dump or if it gets to the laundry, they're going to come over and get you and find
Does
you.
vomitus happen a lot?
Yes.
It's depend on...
Remember, when if you guys give 100 millicuries of I-131 to a patient for thyroid cancer therapy, that's more than enough to give them what they call radiation sickness, okay, the prodrome, okay? And so they can vomit, and then you get to clean it up, okay?
I had a patient with cancer the other day.
We had one in the room, remember? They vomited in that room. Hello, Melinda.
Yeah?
Had to be shut down for several days.
Yeah, well, the thing is that unfortunately, when they designed hospital rooms, that they put linoleum that has seams in it, and so it gets in there and you can't get it out. But anyway, just keep that in mind. That's what you start out with first. Take the clothes off, put them in a, like your decay area.
Outside in the parking lot.
Well, most nuclear medicine departments have pretty good storage areas. I mean, I normally just put it like in a biohazard bag and stick it in there. If it's a hospital gown or something, maybe just consider throwing it, it's not a big deal. Okay, the next thing, contamination of the skin. Okay, you don't want to use hot water because that opens the pores, allows the radioactivity to go in. So lukewarm water, okay, the detergent is like your chelating agent, that's your surfactant that helps make the stuff get washed off. If you do have like Radiac wash, some people use that. My suggestion is that whenever you're handling radioactive material, use gloves. Okay? I didn't have any sympathy for one of my students that contaminated themselves and got a very high reading on their finger ring batch. Okay? Because that immediately tells me that they're not following the policy and procedure of the hospital. Okay, following the cleanup of radioactive spill, decontaminate the area should continue. And so notice it says no more removable. Okay, so as soon as you put your filter paper into your well counter, you know, this is not getting anything off anymore. So that tells you that you've gotten off all the removal contamination. And then the other thing, residual activity is below the trigger exposure rate. So like I said, the trigger rate is usually about 2,000 DPM for most places. Okay, I know you guys, when you looked through this, you didn't have any problems with it, right? Oh, yeah, okay.
Oh, share and
Yeah,
shoot.
the dog ate it, cat ate it. Okay, according to NRC regulations, which of the following precautions should be followed during the administration of xenon? Okay, well, let's remember, shielded trap, and also negative pressure, right?
Does it matter if it's xenon? Because it's only 13 seconds half-life.
What, for xenon? What's the half-life for xenon?
5.24.
Huh? 5.24 days. Okay, what is it for 120? We don't use 127 xenon, but if we did, that's almost 30 days. And it's a higher energy. So, but one thing about the xenon trap, okay, how often does the xenon trap have to be monitored?
That's a week.
Okay, weekly.
There's those beads in there, that stuff,
Yeah.
and the moisture, and what's the
Superman.
Well, you've got one that takes out the moisture.
CO2? Carbon?
Yeah.
Carbon.
Well, the carbon removes the xenon, so you have like it's the activated charcoal.
That's,
Okay, it's called activated charcoal, and then the other one is carbon. It removes the CO2. Turns pink, I think. It's
Yeah.
like purple and then it turns pink. I'm trying to remember what it is.
that's the CO2 one,
Yeah.
and the charcoal, activated charcoal. we use.
Charcoal removes the xenon, and the other stuff removes the carbon dioxide, then you have another one that removes the moisture. It's like those rhyolite crystals that they sell. Okay. I'm having one of the senior moments.
How many questions are Mr. Arkin?
We're almost, for this one? Oh, on your boards?
No, but it's
We're down to the end. There's 5 more. Okay, the volatility of your liquid solutions, remember keeping it in a refrigerator lowers the volatility. If you don't shake it, and then keeping it at its proper pH. Remember, you want to keep it at a pH of about, what? About 5 to 7.
to 7.5.
The note says nurses carrying 5131 require isolation to be advised of the major contamination. Okay, you've got urine, saliva, and perspiration. So basically the bed is going to be radioactive after you get through. Well, what percentage of the iodine leaves the body through urination?
60.
Okay, about 60%. Very good. Most of the stuff in the saliva doesn't really leave because, you know, it gets excreted into the mouth. But anything you put into the mouth, like silverware, plates, anything, is going to be contaminated. Perspiration is very, very small amount, but you know, if the patient is perspiring a lot in the hospital bed, it's going to be hot.
That's why Kaiser, when they give that I-131, they make sure the patient brings sour candy and stuff to eat.
Yeah.
That's to help with the sore throat.
Yeah, what happens too is
So
it helps
it's-
prevent sialitis. Because, yeah, you get, I mean, if you can constantly have the salivary glands putting out the iodine, it's less radiation goes to it. Okay, patient received 175 millicuries of I-131. Immediately following a dose, the patient measured a dose rate of 3 meters, was 35 mR per hour. How much activity remains at 48 hours if using the same counting geometry, the measured dose rate is 7 mR per hour?
So we do that one formula.
There's a formula in the book, in the Ann Steve's book.
But we can't use that one from before, it has another point source.
Oh, no, well, this one kind of works. It's, if you use the same geometry, you can estimate the amount of activity in there.
It's like a quarter of
It's a direct relationship. But I'm trying to remember what page it's on here. So we need the. Well, the way that works, okay, you have 175 millicuries.
half-life is taken into account.
What's that?
Is biological half-life taken into account?
Yeah. Well, remember, I mean, nowadays, if you can show the patient isn't going to be a radiation threat to anybody, you can send them home. But we used to keep a patient in the hospital if they had 30 millicuries equivalent or more. So what they're saying is you have 175 millicuries here, and you're getting a radiation dose of 35 mR per hour. Okay. And so what you want to calculate then, the dose rate is, you want to calculate what's the amount of dose left if you're getting 7 mR per hour. So basically, you set it up like this, and then you cross multiply, and you get 35x is equal to
1225.
1225.
Yes.
So 35 into 1225 is what?
It's 35.
How much?
35.
Okay. So basically, the patient has the equivalent of 35 millicuries of iodine, which means you can't discharge him.
Three less than 30.
Yeah, no,
Less
well,
than
the rule was
7.
that if it's 30 millicuries or less, you can discharge him.
Uh-huh.
You don't have to admit him into the hospital.
If it's less than 30.
Yeah, that's,
7 too, right?
well, yeah. You can either show that they're not going to be a radiation burden, in other words, there's nobody but cats living at home, or there's no kids and other people, then it's okay to send them home, provided they can take care of themselves. But otherwise, if it's 30 millicuries, then they have to be admitted in radiation isolation. So what we used to do was we would give them 29.9 millicuries. So we wouldn't have to admit them into the hospital. Because normally that's just a 24-hour admission, so we didn't keep them in that long. Okay,
And the release criteria for them to leave has to be.
well, usually they, I would say that typically they get down to about background. I normally used to tell them drink a lot of fluids, and then you monitor them every day. And for 100 millicuries plus, it would take about 2-3 days to get it down to background. We used to keep until they were 2 mR per hour. But the thing is, like I said, they still have that 30 millicurie limit, but that's only for patients that are, not like if, they live next door to a daycare and they have little children living in the house, they'll probably admit them, or at least, if they say, well, we're going to stay in a hotel or something away from everybody for 2 days. But that's one of the ways that you can calculate how much activity is left in there if you can use the same reproducible geometry. Then down here it says, according to the NRC, you must remain in isolation to get down about 5 mR per hour. So So that's what you kept measuring them for. You'd have them go to the bathroom a lot, drink a lot of fluids, and that would get it down pretty quick. Okay. And 174, patient has a thyroid cancer. All of the following should be given to the patient who is a mother of a 6-month-old child, except, remember that iodine does come out through breast milk, so not a lot of it though, but significantly enough. If you get 100 millicuries, the mother's milk has about 2% excretion, and then the baby would get 1% of that.
So is it gonna damage the baby's thyroid?
Yeah. I mean, you figure that's a lot of radioactivity for a kid. I figure 100 millicuries, you're going to get 2 millicuries coming out through the milk. And then out of that, 1% is going to go to the, so that's like 20 microcuries equivalent to the baby. So it's not a good idea to have them, normally you tell them, you get a breast pump or something, or switch the child to formula. And last but not least, which of the following items must be monitored for contamination? Okay, everything. Okay. Remember, anything that the patient puts in their mouth, accidentally urinates on, or perspires on is going to be radioactive. Okay? And typically, because 60% of the iodine leaves through the urine, patients that pee in the shower, we had them, believe me. Said, "Why didn't pee in the shower?" Well, how come it's radioactive in here?
Because I sweat a lot.
Yeah, yeah, it's all that sweat washed off. Okay, we've had them pee in the sink too.
What?
The shower was occupied? Or
Yeah, I don't know. Well, normally we give them a private room, but we had this one lady from Vietnam who, she didn't even know what a bathroom was. So I don't think anybody told her, nobody, I had her at County USC, and we tried to explain to her every time she came in. She had this thyroid cancer that was like huge, because she hadn't been treated. She's one of the boat people from 1975, hadn't seen a doctor, and this cancer was just like this huge mass. They took it off, treated her, she survived, but every time we treated her, man, the bathroom was, the shower was like radioactive. Okay, why don't we take an early lunch, come back, and then I'll get you out of here early, okay?